This is part two of chapter four on repetition or iterative structures. So in the first part, we talked about counter control loops, the for loop, where we know in advance how many times something's going to happen. So in this section, we're going to talk about the condition control loops, right? Okay. So in this case, the code block, which will be designated by the curly braces, will continue as long as the stated condition is true. Okay. So let's take a look at the basics of this. It's fairly straightforward. We start with a while loop. We have some condition inside of the while loop. A condition has to be something that evaluates to a Boolean using equals or greater than or not equal to or whatever. Okay. We then have the body of the loop. Okay. And that's going to keep working as long as the condition is true the first time. But keep in mind, at some point, there has to be a way for the condition to become false. Okay. And that's called the terminal condition. Okay. So if not, you have an infinite loop, which goes on to you solve it, basically. Okay. So let's take a look, and then all the code that you really want to execute would be in here. So let's go with a simple version. Let's say we're going to have, so we have to have our initial condition has to be true the first time. Okay. So let's say I'm going to ask the users for numbers. I'm just going to print out those numbers until they enter a 7, just randomly. Okay. So I want n to be set to something that is not 7. Okay. So I can say while n is not equal to 7, okay, I'm then going to I'm going to ask the user for a number, cout, enter an integer. I'm going to say randomly 7 to end. Right? Cn by n. Okay. Okay. Once I've done that, this is going to be a little bit tricky. Not the simple example I was looking for, but we'll work it out. We'll talk about why it's not as simple as I thought. So they've entered a number. Okay. We're going to print out, or we're going to ask them for that number, and then we're going to print out the number. So we can cout. You entered it. Okay. Because we're asking for the number inside the loop, we're always going to have a way out. Okay. Take a look at this, see what issues there are that we're going to have to address. Okay. It should work for most cases. We'll talk about that. So lost my cursor. Found my cursor. Okay, so this one I'm going to compile this. My cursor cooperates. Doesn't like something. What doesn't it like? That looks like I've got a CN going the wrong way. Let's see if that's the case. Nope, that's okay. Yeah, that's always all going the right way. Let's see what the heck it's looking for. Find the first error. Okay. Missing terminating. Oh, I must not have. Interesting to give all those error messages for that. Oh, yeah. It stayed purple, but I didn't pay attention. Okay. Fix that. Let's compile it again. And note that I keep the errors in on purpose. I think that correcting your errors is one of the more important things that we're going to need to learn to do here. Okay. So it's going to ask us for a number that should indent over. Enter a 5, prints a 5, 8, 123, negative 23, whatever. Okay. We're okay. I go 7 to end. It works, except it did exit, which is correct, but it told me I entered 7. I don't really want that. So let's talk about how we could fix that. Okay? So the way to fix this is to ask for the value first outside the loop. Okay. So I'm going to copy the code from here. Okay. Then I'm going to yank that back, move it up here, yank it back. Again, the tab key will fix your formatting. Okay. So now, instead of, I'll get rid of this stuff for now. Instead of printing after I ask for the number, I've already asked for the number once before I get into the loop. So I can go ahead and move the print to be before we ask. Okay. So the first time through, if I enter a 10, it'll print 10. It will ask me. Then if I enter a 7, it will come around and exit the loop before it prints 7. Okay. Let's try that one. Okay. Run this. Now, if I enter a 10, it gives me a 10. Enter a 7, we just exit and we're fine. Okay. So again, let's take a look at what an infinite loop would look like. Let's say we don't do this. Okay. We compile it. Going to be fine. It's not a syntax issue. Going to run it. Enter something. Right. Goes on forever and ever. Control C will stop it. Okay. I'm curious. We've mentioned before, you can do a dashed wall when you compile your program with return on all the warnings. I don't know that it checks for that though. It does not. So you're on your own to catch that. Okay. So again, the issue is that we have to have an ability to move toward our terminal condition. Okay. Okay. That should fix it. No, got the wrong way. Got the wrong way. Yeah, no, that's fine. Right. You print, then you ask. Okay. So this is called a test first loop because the test has to be true the first time that you run it. Okay. So an alternate version of this is called a while loop. It's called a do while loop. Okay. So a do while loop is a loop that is guaranteed to execute at least always one time. Okay. But it's a test at the end. Okay. I have found in practice not to ever really need much use for a do while, but sometimes it can make your code a little simpler. So let's go back and look at the syntax first. So I'll just go down here for this one. So we're going to start with a do, and that's it. A do by itself with the curly braces. Okay. I'm then going to do whatever code I want. Okay. Again, we have to have a way to move toward a terminal condition. Get out of the loop. Okay. And then we end it. Okay. We're going to put our while down here. So while our condition here. Okay. And I think, do I have a semicolon here? Feel like I do. Yeah. We'll see when we do this. Okay. So otherwise, this works the same way. Okay. So in this case, I'm always going to get into the loop no matter what. Okay. So it's always going to execute at least one time. Okay. So I can cut this stuff out of here. And we're not going to see a lot of difference, to be honest, in this behavior. Make sure that is where that semicolon goes. We're entering a number. It's now one thing in this case, this one absolutely will print the 7. We can't say out of it. Okay. But we could if we wanted to, because the test is at the end, we could change the order here. Okay, so I don't have to ask first. And I can move this to below. So since the test is at the end, I can do that after I've entered. Okay, so now the first time through, if I enter a 7, no, it'll still do the 7. Yeah, I would have to do some more work and maybe put an if in there to avoid that from happening. Okay, let's just make sure that I have that I did put that semicolon in the right place. Oh, I didn't actually say anything. It's the condition here. It's whatever you want while to repeat the other one. While n does not equal 7. Is that all okay? Yeah, so that is what the semicolon is. Okay. So that's what a do while looks like. Its only claim to fame, and the only difference from a do while and a while, is that you're guaranteed it's going to execute at least one time. Okay. But you can usually do the same thing if you want by setting a condition to be true before you go into the while loop. Okay. Um, so that's the counter. No, sorry, we had the counter control loops. That's the for. This is the condition control loop. Okay. One thing I will end on here is that if you wanted to only learn one loop, you could do a while loop for everything. Okay. So let's take a for loop that we've done before. We got for int c equals 1, c is less than or equal to 10, c plus, we're going to c out c. That's all we're going to do. Okay. We can do the same thing if we want. Okay, let's do an int I instead. We have to set our initial condition ourselves manually. Okay. We're going to say while the condition that we have here. Okay. So while I less than or equal to 10. Okay. Then I'm going to see out I. I'm going to say I plus plus. And there we go. Okay. These should produce exactly the same thing. But I do. Well, I didn't like my end. I'm doing int end. Oh, I think it's just saying it was unused. Yeah, unused variable. That's because I did it with the dot wall. It doesn't matter. It's still executed. It's just a warning. Yeah, we're fine. Okay. So if we run it now, you see that these two loops are identical. Okay. So if you, for whatever reason, you didn't ever want to use a while loop or forgot how to use a while loop, then this same thing is the other way to do it. Okay. It's otherwise beautiful. In fact, I think I can do this again because because I declare it within the for, that should be legal. If not, it wouldn't be legal. It's perfectly legal. So that works as well. Okay. So yeah, that's the conditional loops, and they'll go on as long as you want. Again, a for loop is not going to have a problem with infinite loops, but a condition control loop will. So you have to make sure that that condition that keeps it moving has the ability to become false.